This is Mathematics Let Review Part 4. You can also use it for other kinds of examination aside from the licensure examination for teachers. For our first part, we will be tackling problems involving greatest common factor. This is our first problem. April is campaigning for student council president and plans to distribute some campaign materials, 20 flyers and 16 buttons. She wants each class to receive an identical set of campaign materials without having any materials left over. What is the greatest number of classrooms April can distribute materials to? So, there are three methods that I'll be presenting in solving this problem. So it's all up to you which one you are comfortable using. So all throughout the video, I'll be using these three methods. If there are other methods, so more or less they are similar to this, and it will also be resulting to exactly the same answer. So what we will be doing is for prime factorization, we will be writing 20. So by the way, prime factorization is our first method. So we will write both 20 and 16 here. This is also known as factor tree. So to factor, we need to write all numbers, all the factors of 20 and 16 that are primes. So we start with 2. 2, that's the smallest prime number that we can give. So 2, a number which will be multiplied to 2 that gives you 20 is 10. So since 2 is already prime, we just have to write it again and find also the prime factors of 10. So we can also write 2. And a number when multiplied by 2 that gives you 10, we have 5. Is 5 a prime number? Yes, because the factors of 5 are only 5 and 1, or 1 and itself. So we move now to our next number, 16. So again, we can start with 2. A number when multiplied by 2 that gives you 16, that's 8. We bring down 2. Numbers when multiplied, uh, you know, we will have 2 again because 8 is divisible by 2. And then we have 4. Then we bring down 2. And then factors of 4, we have 2 and 2. So to get the greatest common factor, we are going to have the pairs 2 and 2. 2 and 2 is here, and 2 and 2 is here. So we have 4. So we have 4 here and 4 here. That would mean that the greatest number of classrooms that April can distribute the materials without having any leftover will be 4. So our answer is 4 classrooms. There. So let's try to see if we will arrive at exactly the same answer using the next method. So our next method is the Lauder method. So what we do, more or less, they are similar but slightly different. So what we do is we write 20 and 16. This time they are side by side, separated by a comma. And we write this one. So we always start asking if the numbers or the pair of numbers are divisible by 2. Is 20 divisible by 2? Yes. Is 16 divisible by 2? Yes. So we start with 2. 2. So 20 divided by 2 is 10. And 16 divided by 2 is 8. And then we divide again. Is 10 divisible by 2? Yes. Is 8 divisible by 2? Yes. So we have 10 divided by 2 is 5. And 8 divided by 2 is 4. Is there a number that we can divide to both 5 and 4? No. So we end here. We are only going to multiply the numbers on the left side. So 2 times 2 is 4. So it will tell us that April can distribute 4 classrooms. The greatest number of classrooms that April can distribute the materials without having any leftover would be 4. 4 classrooms. And that is the second method, and we call it the Lauder method. We now moved on to the next method, and we call it the listing method. So how do we go about it? The listing method, all we need to do is we list down the prime factors. So we have 2 times 2 times 2 times 2 times 5. Maybe we can use times, right? So we'll be making use of the multiplication symbol, times. And then we have 16 here. 16. So 16. Then we multiply it by 2 times 2 times 2 and times 2. So what we do is we just look at the pair of numbers. That's one pair. And that's another. So it would mean that um, the numbers that is common to both is 4, which is similar to our two other previous method, the same answer. So it will tell us that April can distribute 4 classrooms without having any leftover. That is the greatest number of classrooms that she can distribute the materials without having any left over. Okay, so we have solved our first problem. We now moved on to our next problem. So our next problem states that May wants to create snack bags for a trip she's going on. She has 6 chocolate bars and 10 pieces of candies. If the snack bags should be identical without any food left over, what is the greatest number of snack bags May can make? So again, we will be using all 3 methods that we have used in the previous problem. So we start with prime factorization. So we start with 6 We'll have to make use of the red 6 and 10. So factors of 6, we have 2 and 3. Factors of 10, we have 2 and 5. And we have all numbers, all factors that are prime. We can no longer factor any of the factors that we have presented. So what is common in both? We have a 2 here and we have a 2. So it will tell us that May can have a maximum or the greatest number of snack bags May can make with her 6 chocolate bars and 10 pieces of candies would be 2 bags, 2 snack bags only. So let's try to see if we have exactly the same answer uh, with the second method, which is the ladder method. So for our ladder method, we write 6 and 10, and we ask ourselves, are 6 and 10 divisible by 2? And if our answer is yes, then we write 2 there, and we divide 6 by 2, that's 3, and 10 by 2, that is 5. So, can we divide 3 and by 5 with a prime number? No more. So, it will tell us that 2 is our answer, similar to the previous method, the prime factorization. So May can have the greatest number of snack bags May can make with the 6 chocolate bars and 10 pieces of candies is 2 bags. And we have the last method. That's the listing method. So for our listing method, we just have to list the factors of 6, that's 2 and 3, and the factors of 10, that's 2 and 5. So we are going to look at the lists. We have 2 as the common um, factor of the two numbers. So our answer is the same to all 3 methods, that that the greatest number of snack bags May can make with 6 chocolate bars and 10 pieces of candies would be 2 bags. So this is the third problem. June is making emergency preparedness kits to share with neighbors. She has 12 bottles of water and 16 cans of food, which she would like to distribute equally among the kids, with nothing left over. What is the greatest number of kits June can make? So we start with our prime factorization or factor tree. So we write our 12 and we write 16 also. So is 12 divisible by 2? Yes. So we write 2 here, and 2 is multiplied by 6 to get 12. 2 is already a prime factor, so we just bring it down. 6 is still a composite number, so we still have to factor them out. And 6 is divisible by 2, and that should be paired with 3. also a prime number to result that will result to 6. So the prime factors of 12 are 2 times 2 times 3. So we move to our next number, which is 16. So again, we start with 2. 2, 16 is divisible by 2, and that's 2 times 8. That results to 16. So we bring down 2. 8 is divisible also by 2. So that would be 2 and 4. So we bring down 2. And we bring down 2. And 4 is also divisible by 2 and 2. So we have the factors of 16 are 2 times 2 times 2 times 2. But we are only going to take that is those factors that are the same with the other number. So that's only 2 and 2 and 2 and 2. So in this case, if we go back to our problem, the greatest number of kits that June can make with 12 bottles of water and 16 cans of food is only 4. So we have 4. That is applying the prime factorization. Let's try to see if we will have the same answer using another method. That's the ladder method. So for the ladder method, we write 12 and 16. 12 and 16, is it divisible by 2? Yes, 12 divided by 2 is 6. And 16 divided by 2 is 8. And are 8 and 16 divisible, are 6 and 8 divisible by 2? Yes, so 6 divided by 2 is 3. And 8 divided by 2 is 4. Can we still factor out 3 and 4? Is there something common between 3 and 4? The answer is no. So we only have to multiply the numbers outside on the left side. So that's 2 times 2. That gives us 4. So which is similar to our previous method. So let's see with our last method. The listing method if we will arrive at exactly the same answer. So 12, that gives us 2 times 2 times 3. Then we have 16, 2 times 2 times 2 times 2. So going back, we have 2 and 2 is common and 2 and 2 here. So there are two 2's that are on both 12 and 16. So we are consistent with our answer that the greatest common factor of 12 and 16 is 4, or the greatest number of kits that June can make with 12 bottles and 16 cans of food would be 4 kits. Okay, thank you. So that would be our part 4 for the Mathlet review, focusing on solving problems involving the greatest common factor. So don't forget to subscribe like, and hit the bell icon for notifications so that you will be updated with the new videos. Thank you so much and have a good day.